A thread is a basic unit of CPU utilization. It comprises a thread ID, a program counter, a register side, and a stack. It shares with other threads belonging to the same process its code section, data section, and other operating system resources such as open files and signals. A traditional process has a single thread of control. If a process has multiple threads of control, it can perform more than one task at a time. So look at this picture. Okay. The left one is a single thread process. Actually, it has no thread. Okay, the operating system itself doesn't support thread. So we can see the process itself has registers, stacks, code section, data section, or open files. In the right part of this diagram, you can see that it has 3 threads. One process has 3 threads. For the threads, it has registers and stack. And the 3 threads belonging to the same process share the code section, data section, and open files. So motivation. Most software applications that run on modern computers are multi-threaded. An application typically is implemented as a separate process with several threads of control. A web browser might have one thread display images or text, while another thread retrieves data from the network. For example, a word processor may have a thread for displaying graphics, another thread for responding to keystrokes from the user, and a third thread for performing spelling and grammar checking in the background. Applications can also be designed to leverage processing capabilities on multi-core systems. Such applications can perform several CPU-intensive tasks in parallel across the multiple computing cores. In Solaris, creating a process is about 30 times slower than is creating a thread, and context switching is about 5 times slower. Many software packages are multi-threaded, and benefits. The benefits of multi-threaded programming can be broken down into 4 major categories. First, responsiveness. Multi-threading, an interactive application, may allow a program to continue running even if part of it is blocked or is performing a lengthy operation, thereby encouraging responsiveness to the user. This quality is especially useful in designing user interfaces. For instance, consider what happens when a user clicks a button that results in the performance of a time-consuming operation. A single-threaded application would be unresponsive to the user until the operation had completed. In contrast, if the time-consuming operation is performed in a separate thread, the application remains responsive to the user. 2. Resource Sharing. Processes can only share resources through techniques such as shared memory and message passing. Such techniques must be explicitly arranged by the programmer. However, threads share the memory and the resources of the process to which they belong by default. The benefit of sharing code and data is that it allows an application to have several different threads of activity within the same address space. Third, economy. Allocating memory and resources for process creation is costly. Because threads share the resources of the process to which they belong, it is more economical to create and context switch threads. Empirically, getting the difference in overhead can be difficult, but in general, it is significantly more time-consuming to create and manage processes than threads. Fourth, scalability. A multi-threading can be even greater in a multiprocessor architecture, where threads may be running in parallel on different processing cores. A single-threaded process can run on only one processor, regardless how many are available.